In this lecture, I will share parallel combination of resistors. This figure represents parallel combination of three resistors. Suppose R1, R2 and R3 are resistance values of these three resistances. Let us combine the common terminals of three resistances to a battery having potential of V volt. That we call this potential of battery as V volt. So it is clear from this figure that same potential will appear across all the three resistors. R1, R2 and R3 all will have same potential difference across their terminals. And current coming from this battery, suppose it is I, it will be separated into three parts. A part of the current will flow towards R1. Let me call this current as I1. A part will flow towards R2. Suppose it is I2 current. And rest of the current I3 will flow towards R3. So in this way all these three currents passing through R1, that is I1, through R2 it is I2, through R3 it is I3. All these three currents combine together and give rise to same value of current moving towards negative terminal of the battery. So I can write mathematically that total current from the battery is equal to I1 plus I2 plus I3. Let me call it equation number 1. According to Ohm's law, I can write I1 is equal to V over R1. Similarly, I2 can be written equal to V over R2 and I3 can be written equal to V over R3. Using these values of I1, I2 and I3 in equation number 1, we can write I is equal to V upon R1 plus V upon R2 plus V upon R3. Let me call it equation number 2. Let us suppose R is the value of resistance of a resistor that is equivalent to combination of three resistances R1, R2, R3 in parallel to each other. Then if I connect this equivalent resistor to a battery of same potential difference, that is V volt, then because this resistor is equivalent to parallel combination of 3, so it will draw the same amount of current, that is I. After passing through resistor R, it will be same, that is reaching the negative terminal of the battery. So same potential, whole of the potential V will appear across the resistor R. Again using Ohm's law, I can write I is equal to V upon R. Equation number 3, let us suppose. Now comparing equation number 2 and 3, comparing equation 2 and 3, I can write V upon R is equal to V upon R1 plus V upon R2 plus V upon R3. After simplifying, it will give us 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So this result gives us the value of resistor that is equivalent to parallel combination of three resistances. So it is clear that reciprocal of equivalent resistance is equal to sum of reciprocals of individual resistances, which are connected in parallel to each other. This is how we can make use of parallel combination of resistors.